In this session, we'll analyze some problems on frequency domain analysis of Hilbert transform. So let us consider signal x of t is equal to sine omega ct. So finding the Fourier transform of x of t in a usual way. So it is given by x of omega is equal to pi j delta omega plus omega c minus delta into omega minus omega c. So in time domain, the expression, output expression is written like this: y of t is equal to Hilbert transform of x of t given by convolution integral. So in the frequency domain, this convolution integral is nothing but multiplication of two signal. So y of omega is equal to Hilbert transform of x of omega, that is equal to h of omega and x of omega here. So now we are going to substitute h of omega as minus j signum omega, as we have understood from the previous session, response of the system in frequency domain, and the signal x of omega we substitute here. Now you multiply j into j, here is j square, which is minus 1, therefore minus 1 into minus is plus. So now you are going to get pi into signum omega delta omega plus omega c minus delta of omega minus omega c. So now we'll multiply these two signal, that is signum function and delta functions, as written here. So this is signum function, which is defined for omega greater than 0 plus 1 and omega less than 0 minus 1. It is multiplied by the delta function at omega is equal to minus omega c and at omega is equal to omega c with an amplitude of pi here. So when you multiply these two signal, that is nothing but positive frequency yields minus pi and negative frequency yields here minus pi, that is minus 1 into plus pi is minus pi. Therefore we are going to get the signal x omega, x cap of omega, that is nothing but minus pi into delta of omega plus omega c plus delta of omega minus omega c. By taking inverse transform, Fourier transform, we'll get it as cos omega ct. So in a similar way, if we have x of t is equal to cos omega ct, so Fourier transform of this x of t is written like this: it is x of omega is equal to pi of delta omega plus omega c plus delta of omega minus omega c. So now we know that h of omega, that is nothing but minus j signum omega. So what is x cap of omega? Hilbert transform of x of omega, which is given by product of h of omega and x of omega. Substitute two values here and simplify. So we are going to get minus j pi signum omega delta of omega plus omega c delta of omega minus omega c. Now you write the waveform, multiply, we will get the resulting waveform at omega is equal to minus omega c pi and at omega is equal to omega c minus pi. So this indicates it is nothing but delta of omega plus omega c minus, amplitude is minus here, so minus delta of omega minus omega c. Therefore taking inverse transform, it yields cos omega ct.